All right. 4.2, we talked in the first section, we focused on surveys. We focused on selecting people to ask questions to or gather some type of data about. This time we're going to talk about experiments. And so 4.1, a lot of it was about surveys. And surveys are often called observational studies. So an observational study is you observe, record some data, you don't manipulate them or alter their behavior in any way. That's an observational study. And so if we wanted to do some kind of study like that, we would need to observe and record data. And you wouldn't do anything different and give any kind of special different treatment to any other group. In an experiment, we are deliberately imposing some kind of treatment on the individuals to measure their responses and to hopefully make comparisons between the treatments. That's the idea of an experiment. We apply these different treatments to hopefully be able to make some sort of comparison between how the treatments change their behavior. So we do this if we want to, remember last chapter we talked about how just because two variables are correlated doesn't mean that one is causing the other. Because of the way an experiment is designed, that is when we can determine whether one thing is causing the other. Because in an experiment, we try to control for other outside factors and say, this is the only possibility. It has to be that this is the only thing we changed, and so that's what caused it. And so that's what we're trying to get rid of, these outside lurking or confounding variables. So confounding is when we have variables that are very much linked together. And they can be confused for causing the response variable. And so if we don't know whether variable A or variable B caused this thing to happen, and we can't tell which one it is, then that's an example of confounding. So an example is if you're measuring somebody's, how good a shape somebody's in, then you might have, and you have, say, a diet and exercise. Then it's tough to determine whether the diet or the exercise contributed to the person being in good shape. And so that's where you would need to control for one of the variables to make sure that it's not getting in the way of the other variable. It'll be better to see when we talk about some examples, a specific example, but we're just defining some terms here. By the way, this PowerPoint should be already posted on the Canvas page if you're looking for it. So you shouldn't have to, feel free to take down anything that you need to, but it should be already posted on Canvas for you to access. All right. So in an experiment, we are using what are called treatments. And these treatments are the different things that we want to compare with each other to see what effect those specific treatments have on our response. So basically the treatment in this case is going to kind of be our explanatory variable, what we think will explain, and then we are measuring the response as a result of that variable changing. So the overall outline that we typically use is we have our units, we have our people or our plants or whatever we're measuring and gathering data about. We do some kind of treatment on them, and then we measure and compare their response. And the most common type of experiment involves random assignment. So you are randomly assigning people to two different groups. This is different than random selection because that's how we kind of maybe pick our 100 people to choose. Now, in random assignment, we have our 100 people, and we want to put 50 in one group and 50 in the other group. That's what the random assignment does. It gives, here are the 50 people we want in group A, here are the 50 people we want in group B. So completely randomized design is the most common type of experiment. And that is what I just described. It's some of the group gets one treatment, some of the group gets the other treatment. Or if there are 3 treatments, a third of them get treatment A, a third of them get treatment B, a third of them get treatment C. That's the most common type of experiment, is this completely randomized design. Kind of like how the simple random sample is the easiest type of sample to take, where we just choose a group at random. Completely randomized design is we just put them into our 3 groups. And so here's how that diagram will look. And if you're describing a randomized design, you will need to say 3 things in your description. Thing number 1 is random assignment. You should say that you're randomly assigning things into groups. The second thing that you need to make sure to say is you need to say what your treatments are. So we're splitting them into groups. How are the groups distinguished? What treatment is group A getting, group B getting, group C getting, etc. And then the thing number 3 you need to say is what is your response variable? In other words, what results are we looking for? What results are we measuring and comparing with each other? So those are the 3 things that we need to write out and say when we're describing how to design an experiment. So let's look at some examples of these designs and making these designs. So this is in our example sheet here. So now we're describing the experiment and we're identifying different pieces of it. So I'll give you a moment to read. We're going to do 2 examples today, and then we'll do the other 2 tomorrow. All right, explanatory variable. What's the variable that we're interested in that we might think is causing changes? So adding a fertilizer in half the pots, and then water 8 of the plants with 0.5 gallons of water, 1 gallon of water, and 1.5 gallons of water. All right. So those are the things that we are doing the treatments on. So we're actually comparing 2 different variables here. Fertilizer and amount of water per day. So those are the 2 different variables. This is actually a block design, which we'll talk about tomorrow. But we're just getting us acquainted with the terminology here. Response variable. Weight of the tomatoes. Experimental units. So in other words, what are we assigning to the groups? Experimental units are the tomato plants. So they are, there's 24 of them. Treatments. The treatments we are doing are, there are 2 different treatments because we have 2 different explanatory variables. So we have fertilizer versus no fertilizer. And then we have 0.5 gallons versus 1 gallon versus 1.5 gallons. So those are my different treatments. Notice that they have described all 3 things that we are doing. So we need to talk about how we randomly assign them into the pots. We need to say, here's the treatments, fertilizer in half. Here's 8 that has 0.5 gallons, 8 that has 1, and 8 that has 1.5. That's describing what the treatments are that we're doing. And then what's the response variable that we're measuring? So next we're going to practice describing that ourselves. Students in a caffeine experiment. So just to give context, before we give our answer. We want to know if this was an example that they gave in the book. Caffeine, E-I-N-E, has an effect on a student's pulse rate. That's the experiment that we want to do. So we have 30 students, and we want to assign them to different treatments. So, solution. First off, we want to say that we're randomly assigning. So randomly assign 15 students randomly assign 15 students to each group. We can do this by, I had said that a common method is taking names and putting them in a hat, so that's what we're going to use here. You can use random INT and pick the 15 people from 1 to 30, but what I'm going to do is we're going to say we can do this by putting each of the 30 students' names on slips of paper. And the first 15 names that get selected go to group A. The rest go to group B. So that is our random assignment. That's thing number one we need to say. Thing number two we need to say is the treatments. So what does group A get? What does group B get? Group A will receive a drink with caffeine in it, while group B will receive, well, we want to have a control. I'm going to talk about this tomorrow, but we want to have a control. So we don't just want to compare caffeine to nothing. We want them to not be able to distinguish between the two treatments, so that we don't think that there's some kind of placebo effect going on, which I'll talk about tomorrow, but which you should have read about. We don't want to think that there's some kind of placebo effect going on, so we want to make sure that the treatments are as similar as possible, and the only difference between them is the caffeine. A similar drink with no caffeine. After the students drink, record their pulse rate. Record and compare. So we have said our three things. We have described how we're randomly assigning into groups. We have given our two treatments that we are comparing between. We're making sure the only difference between the two treatments is one gets caffeine, the other doesn't, so that we know caffeine is the determining factor. And then we're saying what is the response variable that we're comparing the results about. In this case, it's their pulse rate. We want to be specific about that. Don't just say compare results, say what results we're comparing. And a lot of times, a lot of people like to use a diagram for this, similar to the one that was over here. This kind of diagram. So in this case, it would look like we have 30 students. And over here, we're going to put randomly assigned. Into our two groups. This is going to have the caffeine drink. And here's group B. Group B is getting no caffeine drink. So we've said that we're randomly assigning. We've said what the two treatments are. And then we're going to say what variable we're comparing. Compare pulse rate. And that's what these completely randomized designs should look like. We have a certain group of people. We're assigning them into our different treatments. And then comparing whatever result we're comparing. We should be specific about what variable that is.